Good morning, everyone. Welcome to the inaugural edition of the Padma Vibhushan Dr. G. Madhavan Nair Annual Lecture Series, organized by the Aeronautical Society of India Student Chapter of CET in association with the AeSI Trivandrum Chapter. Firstly, we welcome our dignitaries on stage, the Principal of College of Engineering Trivandrum, Dr. Suresh K., our Chief Guest, Dr. S. Somanath, the President of the AeSI Student Chapter CET, Mr. Abhimanyu A., and the General Secretary of the Aeronautical Society of India, Student Chapter CET, Abhinavi P.S. Welcome you on the stage. The Aeronautical Society of India, Student Chapter of CET, is the first student chapter in Kerala of one of the most illustrious professional bodies in India, whose first chief patron was none other than Pandit Jawaharlal Nehru. The chapter was inaugurated on September 27, 2024 by the then chairman of AeSI and our chief guest today, Dr. S. Somanath, at the Vikram Sarabhai Space Center.
Firstly, a hearty welcome to our respected principal, Dr. Suresh K., who is presiding over the function. Our most distinguished chief guest, Dr. Somanath, Deans, HODs, our very own Dr. Abhilash Surya, the faculty mentor of the AeSI student chapter, our dignitaries from AeSI parent chapter, respected dignitaries, and our entire audience. Today, we have the inaugural edition of the Padma Vibhushan Dr. G. Madhavan Nair Annual Lecture Series, named in the honor of a titan of Indian science and technology, a man whose mission helped India touch the stars. Dr. G. Madhavan Nair served as the chairman of the Indian Space Research Organization from 2003 to 2009, a period that marked some of the most glorious chapters in Indian space history. An alumnus of the 1966 Electrical Engineering batch, he is the foremost and topmost among the illustrious line of space scientists from our alma mater. Under his dynamic leadership, ISRO achieved the remarkable feat of launching 10 satellites in a single mission aboard the PSLV C9 in 2008, a world record at the time that announced India's arrival as the premier space power. His crowning glory was spearheading Chandrayaan-1, India's first mission to the moon, which not only placed India among an elite group of lunar exploring nations, but also made the groundbreaking discovery of water molecules on the lunar surface, a finding that captured the attention of the entire scientific world. With over 4 decades of distinguished service to ISRO, Dr. G. Madhavan Nair contributed to the development of launch vehicle technology, satellite systems, communication infrastructure that transformed India's technological landscape. He is the recipient of the Padma Vibhushan, India's second highest civilian honor, a testament to his extraordinary contribution to the nation. Beyond his technical brilliance, Dr. Madhavan Nair is a visionary, a mentor, and an inspiration to an entire generation of scientists and engineers who dare to dream beyond the atmosphere. We now invite the President of the AeSI Student Chapter, Mr. Abhimanyu A., to deliver the welcome address.
Respected Chief Guest Dr. S. Somanath, respected dignitaries from the Aeronautical Society of India, Trivandrum Chapter, our principal, faculty members, invited guests, and my dear friends, everyone, good morning to everyone. On behalf of the Students Chapter of Aeronautical Society of India, College of Engineering Trivandrum, it is my great privilege to welcome you all the inaugural edition of Padma Vibhushan Dr. G. Madhavan Nair Annual Lecture Series, organized in association with Aeronautical Society of India, Trivandrum Chapter. Today is truly a proud moment for CET because we are honored to have us with us Dr. S. Somanath sir, former chairperson of ISRO and national president-elect Aeronautical Society of India. Sir, we warmly welcome to you in this program, and we truly grateful that you have taken this time with us here at this morning. We also extend a heartfelt welcome to our representatives and members of the Aeronautical Society of India, Trivandrum Chapter. Welcome you all. We warmly welcome our principal, Dr. Suresh K. Sir, welcome sir. We warmly welcome our HODs, faculty members, students, guests present here today. Your presence added a great value to this event and encourages the student community. Thank you all, and I hope this session inspires each of us to this bigger, work harder, and contribute meaningful to the Indian's future in science and technology. Thank you everyone.
May I now invite Principal Dr. Suresh K. to deliver the presidential address.
Good morning. Chief guest, Dr. Somanath, office bearers of Aeronautical Society Student Chapter, distinguished scientists and esteemed alumni from and members of Aeronautical Society of India, faculty members and my dear students. It's really a privilege to stand before you at this August occasion of beginning of a new lecture series named after great Padma Vibhushan Dr. J. Madhavan Nair, distinguished alumni of College of India in Trivandrum, who has played a critical role in making India into a superpower in space technologies. And we are blessed with the presence of Dr. Somanath, who has taken the baton from Madhavan Nair sir and placed India in the topmost level of space operations and making a commercially successful entity, that is space. Right? So if you consider the space technology, it touches every facets of our life, in communication and defense and agriculture, everywhere. Right? So we need more talent to work in this field. So it is very important that we motivate and empower students to work in this field. So Aeronautical Society of India student chapter is taking that role, and this initiative is really appreciated because we need to have depth and breadth, right? Both are involved. Right? So these occasions like distinguished lectures will give you the opportunity to interact with scientists and researchers working in this field, and which will impart you more knowledge, and you should make maximum use of this such opportunities and to bring talents to this institution and to have more interactions and more meaningful work to be done in this field. We have different clubs working here in this field, and all are actually contributing for professional development of students. But we need more depth in all these activities, technical depth, also breadth, right? So we wish to have more technology-oriented projects coming from College of Engineering Trivandrum. I believe that such endeavors will help very much in this direction. And we need to have technology creators. We don't want technology users or tool users anymore. We want tool creators and knowledge creators from our institutions. I hope that initiatives of Aeronautical Society of India Student Chapter will be working in this direction, and I take this opportunity to congratulate the organizers of this event. So this is a very great beginning of this lecture series. I don't want to extend more. I once again welcome all the dignitaries on behalf of College of Engineering Trivandrum to this function. Thank you very much.
Now, let's proceed to this personal conclusion, Dr. G. Madhavan Nair Lecture 2026 on global space tech innovations and India's aspirations to be delivered by Dr. S. Somanath. Before we begin, let's give a small introduction about Sir. Of course, Sir himself needs no big introduction, but nevertheless, from our side, we would love to give you an idea. Dr. Somanath served as the chairman of the Indian Space Research Organization, AeSI, Secretary of the Department of Space, and the chairman of the Space Commission. Under his dynamic leadership, India achieved historic milestones, including the successful soft landing of Chandrayaan-3 near the moon's south pole, a moment that filled every Indian's heart with pride. An alumnus of PKM College of Engineering and a gold medalist from Indian Institute of Science, Dr. Somanath has dedicated nearly 4 decades to advancing India's launch vehicle technology, contributing significantly to PSLV, GSLV, LVM-3 and other major space missions. His journey from a small town in Kerala to leading one of the world's most respected space agencies is truly inspirational for young engineers like us. Beyond his technical excellence, he represents perseverance, innovation and visionary leadership. His work not only strengthens India's position in the global space exploration, but also inspires millions of students to dream big and to dream free. We warmly welcome you, sir, to deliver your lecture.
Good morning, all of you. Thank you, Aeronautical Society of India, College of Engineering Trivandrum branch. Really, I'm honored to be here for the first talk series where the Padma Bhushan G. Madhavan name is invoked. I must tell you that he has been my guru and mentor, and the first boss. In fact, he was not the immediate boss, but the person that I reported after joining ISRO in the PSLV project. The project director, Dr. Srinivas, was not there on that day, so I had to go and report to Dr. Madhavan, who was associate project director at that point in time in PSLV. But then later, I had the fortune to watch and witness the evolution that happened in the launch vehicle technology led by him during the PSLV days, and also work in projects like GSLV Mark III and get the project approved when he was the chairman of ISRO. Work in that project for many years and then reach its conclusion of successful launches that is happening now. So a journey that happened in ISRO is something really phenomenal, and I am really thankful to the organization for making me what I am today. But post-retirement I am really enjoying now, especially in teaching students now. I am a professor now. At the Indian Institute of Science, visiting professor, delivering lectures on system engineering of launch vehicles. So it's really something interesting to go back to blackboard with chalk, not PowerPoints. So now I'm not going to talk with PowerPoint, of course, but I love to speak with blackboard and chalk. In fact, I started enjoying it now. Also work with a lot of startups and industries in this sector, especially space sector, where I see there's a great opportunity and real energy and enthusiasm in youngsters. So mentoring them and helping them to grow, scale and envision the future is something which is very passionate for me. So I thought that that's something that is important for all of you, especially students at a college level, need to understand how this sector is really evolving and possibly find some place for you with that. I think if that is possible, then my talk will be useful. I will go through it very quickly. The PowerPoints are just for show only, because some color is required to speak, but you do not have to pay attention to what is there on the screen. But for me to get cue for what I want to speak, I think it will really help. Let me start with the global space ecosystem. I think if you look at the global space ecosystem, I think the times when the superpowers in space were fighting for capability in space is long back before over now. I think the evolution is now moved over to a different regime when private space actors are defining what is needed in space today. The launches that are happening are in hundreds. Now, it was never imagined in the past that space agencies could ever do this. Launching them in every week in succession and launching 10,000 satellites in orbit in a very short period of time. Bringing internet directly from space to your device was never ever imagined. the ability of space to control warfare, surveillance, and many other capabilities have been now demonstrated to an extent that we know that it can really transform the power equations. Now we are talking about moving the data centers to space and also do the AI computing to space, and new architecture of constellation satellites are emerging. Of course, the stories of going to Mars and colonizing has been going on for the last so many years. Nothing really materialized. That may not become materialized in the immediate future, primarily due to the issues related to economics of operation, profitability, etc. But still, that ideas are very strong. People like Elon Musk is still developing big rockets that can take human beings to Mars. But he's also thinking about using rockets to transport human beings across continents. I think all of these are really interesting things. But the most interesting thing are the one which I would like to talk to you now. Now look at the communication. The same slide which I am putting it in text form is that the communication side is now moving away from the geostationary. I think all of you know geostationary communication. When you do a relay type of communication where you send a signal up there, you can get it back anywhere on a distributed platform and you can communicate from one point to the other. But then the LEO constellation enables you to really get a global communication faster from space. That is really significant. And this comes out of something called constellation satellite. So, and we thought that building a satellite is a 10-year project, but it's no longer. It's a very short-term project now. Hundreds of satellites, like in an automobile factory, will come out. And I had an opportunity to witness some of the early work of companies like OneWeb. They were building their first set of satellites in a small room like this on a production line. And how they build satellites in one week. He said that in every week I will produce one satellite. I never imagined that they are really going to do this. The way from one station on the rail it was moving and finally getting assembled and tested. There are only 10 people working on it. And a supply chain of hardware and components coming like truckloads of tires and components coming in an automobile factory. You should go and see an automotive factory how they automate their manufacturing processes. Where the car manufacturer don't actually manufacture anything there, they are only putting things together in a big factory. So similarly, a factory of a satellite building has come up. Now it is a reality. I mean, I would imagine that commercial electronics will enter into space. And we all space people believe that the space is something very complex thing and every electronics device and chip must be of special nature, radiation hardened and complex devices. But today, the chip that is coming out in market goes into electronics satellites very early, which allows the satellites and systems to become more compact, more power efficient, more sometimes more fault tolerant by the architecture of it and not by radiation hardening. So this is another thing happening. But the utility of space is also important. It goes to the strategic, surveillance, safety, IoT, agriculture, drone piloting, for example. And all other things I mentioned, AI, infrastructure, the human, interplanetary travel, and other technologies that get into space faster is additive manufacturing. For people like you understand that additive manufacturing is a disruptive technology, but it didn't find much use in other technology domains. But space has adapted it very fast, and they are using it much more than even aircraft industries and other industries. And the whole crux of the point is that ideation realization is very, very fast today. If you do it in 5 years, 10 years, it's not in the business at all. And if you really look at the space in terms of spacecrafts, you see advanced satellite systems, data centers, small satellite constellations, civil solutions still are very dominant because you see you need to observe Earth, you need to look at the agriculture, weather, and many other parameters which are required for civil society to be used for space. It still continues to remain as a very important area. But surveillance becomes much more dominant activity of satellites today. Everywhere I see companies building constellation satellites specifically looking at understanding what your neighbor has. Because eavesdropping is now becoming a very important topic. Of course, you talk about space tourism, not taken off big way, but still it is happening in some way. Occasionally you see launches happening. And talk about interplanetary exploration, space mining, still being talked about and it's not dying out, but it is not really becoming a commercial entity even now. But there are activities there. But another important area emerging is called space situation awareness. When there are 20,000, 30,000 satellites in space, their collision, how to handle that, how to mitigate debris problems, how to bring back satellite from space back on Earth, all becomes important. So how to track these satellites? When you have a lot of roads and the traffic is very less, it doesn't matter you have traffic signals or lights. No, but when the number of vehicles are increasing very large, you need to have control. You need to establish traffic lights, signals, signaling protocols. Sometimes build new islands, etc. It's exactly the same thing is happening in space now, creating protocols on how you really handle big traffic in space. So, other trends, if I quickly analyze, I mentioned some of them already. First and foremost is a great opportunity for our country like India. There are not many rockets available to launch satellite in space. It's a very interesting story. Though there are a lot of spacefaring nations like Russia, China, America, India, Japan, Europe, but rockets available are not many. India, we hardly launch 3-4 per year, maybe 6. America launches hundreds. China also has the ability to launch 50s and hundreds. Russia has few tens. And Europe launches 3-4 in a year. That's it. And where do you go for launching your satellites? In numbers. And the entire rockets of Elon Musk he uses for launching his own satellites. He doesn't give much to others. But he charges heavily, though he says they are very low cost satellites. So for anyone to go to business and markets, rockets are simply not there. And this is a great opportunity for companies who are working in India to build low level, low cost rockets. Now that's a big opportunity. Reusability is the big thing, but nobody is successful in reusability yet, other than Elon Musk. Everyone is trying. China is trying, they have done some demo, Russia is not even trying, and Europe has no plan immediately, they have been doing a small demonstration. India is talking about it, not even done yet. So, reusability is the buzzword, but success is eluding many people. Of course, other points like a high resolution. And we all imagine from space you can see only kilometers. And it is not true today. You can see centimeters now. One of the best images that are being supplied by the global companies are 30 centimeter, 25 centimeter resolution. And some of them are even 10 centimeter resolution, but it's not available to the public. It is available to some strategic companies. So, and this is being achieved through not just by big satellites. And I have seen companies like Planet Satellite, which is very, very cute and small. It's only A4 size paper, maybe a little cube, and it is able to produce 30 centimeter resolution images. And this is not done by optics alone, it is done by computational imaging. And a lot of algorithms go behind it how to create high resolution images through subsampling and the new development of technologies and sensors in satellites. And this is wonderful to see. And other points which I already measured and talked about, I want to talk about even cloud, how you use cloud in spacecraft. Also interesting to see how technology directions are going on in space. Very interesting is you talk about flexible spacecrafts, flexible payloads, where high throughput is important, quantum, opto-quantum is integrated, and communication is now no longer in RF. We know high throughput requires optical communication networks. For example, the Starlink satellites are talking to each other, and this data transfer takes place at very high data rate possible, and that is all done through optical communication. So the optical links which are established between satellite is really working very well across the globe, but optical link from satellite work is still not fully operational because of many reasons, because of atmospheric inclinations and ground issues, etc. But this is a very interesting area. Securing communication through quantum is another important area which is evolving. Similarly, in imaging, you have seen multispectral imaging is the thing. You can actually look at it with your naked eye, but when you use through hyperspectral and multispectral, you can see images in much more different way. Look at the spectrum, the graph of the image. You can actually classify materials. Find even if you park at quarantine under the tree or under the camouflage, you can actually identify them. Look for minerals. And many other things if you have retrospective imaging. Change detection becomes important. IoT, PNT services become important. PNT stands for position, navigation, timing. GPS is the PNT services. Now, people have started discussing what is automated GPS. And how do you really do a global GPS when you have 20,000 satellites? You don't need GPS. You can use them to do GPS based on a precise timing control from ground itself. So what are the algorithms now which you can actually work in a different way than atomic clocks. All of you, I don't know how many of you know that these satellites carry something called atomic clocks, which are very precise timing devices, and each of them carry multiple atomic clocks. Without them, GPS will not work, and our Navic also won't work. Now there is a serious discussion how to get rid of them, and how you can manage them without having an onboard atomic clock, and how you handle from signals from ground. And there are architectures evolving, possibly this will happen. And what really will happen is, we will see satellites using communication, navigation, as well as Earth observation into one entity, and they will not be finding different satellites for different purposes. Of course, exploration is a very key area where you see still a lot of investment and money is being pumped in by people, especially for human space flight. You know, America is once again going to moon. They have been trying to put their SLS in the launch pad now. Last week they have decided to withdraw back again, check once again for leak. I don't know how many of you follow space news on a regular basis. So America is once again going to moon, and the first launch of 4 people are going to have going around a travel around moon and not landing in moon. They are coming back, and then possibly in a few launches from now they will go back to moon. So essentially, summarizing this, you see high throughput satellites. I know the electronics people are here. You know what is high throughput. You know, if you want to get a very high throughput satellite, what type of features are needed. Here again, there are techniques like digital beamforming and things like that. Satellite mobility, market demand meeting, new bands for communication of satellite. For example, bands like Q, V, and W bands and optical bands are not used extensively in space communication yet. I think exploring these bands and using them becomes important. Quantum is another important area. You know, quantum communication and quantum key-based encryption is a very important domain, which you can do actually in optical communication, terrestrial optical communication. If you use quantum keys at multiple points, you can actually encrypt and send signals in the optical communication domain through crypto technologies. And similarly, now we see data becomes important item. I know you are now in the age of AI. Space is also connected with AI now. And how do we really gather all this information and make sense out of it and use AI engines to drive this? So it means collecting data, analyzing data, taking decisions. What are the type of decisions you talk about? For example, I'll tell you, ISRO today we have hardly 50 satellites, and every day some people have to sit in a terminal and look at each of the satellites' health, and if they find any problem, they have to take corrections, upload commands, and send them. And when you have 10,000 satellites, what do you do? You cannot put anyone there and do this work. And you need to do it automated. The whole thing is to be automated, and decisions are to be taken, commands are to be uploaded. And if you are doing imaging of some places, commands are to be generated, imaged, data retrieved, collected, sense made. All this happens today on a data-driven algorithmic system. It's not done by humans any longer. I think that is a big change that has happened in the sector, still not into our country yet. I think this is a big possibility today. And analysis of the data becomes important. For example, you know, Google gives you the map where you are. If you lay a new road here somewhere, it will appear in the map. I don't know who comes and puts. Your panchayat cannot be knowing that a new road has been built, but Google knows that a new road has been built because it does that image analysis based on a certain periodicity of usage, and he updates it in a very frequent manner with great algorithm, because nobody actually picks it physically. Thus, from the image, extraction of road is actually a feature which is an intelligent feature. They do this extraction and update the maps on a regular basis, where the utility is actually very high. So these are things which is really happening. We can see that in Google Maps, when there is a repair of a road and diversion happens, it reflects on the Google. So who comes and does it? I think you should be knowing why this is happening in a very dynamic manner. Similarly, imaging also becoming a different way. Earlier we thought that we can send a few satellites and image Earth, but no longer. For example, if a missile is going to be launched, and then somebody has to track it. Now, when America and Russia were fighting, the missile tracking was using radar systems. You know, there was a Star Wars time when Russia established their set of radars at some places, America established their set of radars in US and other places, and they were watching each other, waiting for the missile to come and attack us, but no missile came ever. And now these radars are being used for tracking satellites. Now the technology is also changing, and they don't no longer require radar. They can track it from space. So, and when you have 10,000, 20,000 satellites in space, it's very easy for tracking any missile. Only thing you need to have a sensor that will track you the thermal information of the missile plume, and then hand over from satellite to satellite to continuity of tracking. So an algorithm is being developed where you can actually thermal image and get the information trajectory, pass on the next satellite. So over the continents and oceans, you can actually track a satellite without even having a radar. So this is a possibility, and this requires an architecture of satellites which is multiple layered satellite architecture. And this is being talked about and being built slowly by powerful nations. And we also have to do this if you are to really survive in the new age of complex situations. And when you come to defense, you see huge possibilities of space. For example, I already mentioned about early warning satellites, which will actually give you warning of missile launch from somewhere. Somebody is coming towards you, can actually warn, awareness, etc. Space domain awareness, I already mentioned, where you talk about satellites trying to damage somebody else's satellite. And don't think that these are fictions I am talking about. It actually happened for some of our satellites, the Indian satellites. Our good friend came and walked around some of the satellites. We have proof of their imaging being done around our satellites. And this is actually happening. So we need to keep track of that and how do you really look at it. And when something is at 36,000 kilometers or even 500 kilometers, how do you actually see that? You need to put observatories there to watch for somebody coming nearby and causing damage for observations. So this has an optical and IR images, and new technology has recently emerged. It is based on telescopes. One company in France, I have seen it, they have established around 35 telescopes across the world, and these telescopes are sitting on some building stock. Nobody is there. Fully autonomous, and it is connected to a control center in France. He can control all the telescopes, and all the data comes from these telescopes there. And using a synchronous operation of these telescopes, he can find out the moon, the trajectory of every satellite. So it's a beautiful architecture. I mean, people believe that it is very difficult to use, and the telescopes are very small telescopes, just hardly 1 meter in size. You won't even see that if you turn a rooftop. And they are servo-controlled telescopes which you can actually operate remotely and get this data in real time and provide this data globally as a service. Such system I could go and see the control center, and beautifully they generate the data and sell it now globally. Similarly, there are topics which are coming in wartime as well as submarine ocean detection. Ocean is a vast place where you cannot even put your ships to watch. Somebody is coming, a friend or foe is coming, and you cannot deploy your navy across the place, across oceans. So how do you do that? You do that with satellites. Now, you can watch and see how ships are moving, which is a friend ship, which is a foe ship, it's a registered ship, a non-registered ship, whether it is sending signals or not sending signals. All this can be found out today. And possibly you may not know that India already has established our own monitoring system in this country using, of course, some external help. Similarly, we have putting up plans to look at how to detect submarines even. When you go deeper, you cannot detect, maybe very close to the surface possibility of detection still there. So all of these are interesting things that are happening across the world, but then what India is doing, I think India has already announced something for us that by 2047 we will also target going to land on the moon and Indian on the moon. I think you will wonder why you are doing this at this point in time in this country when everybody has gone to the moon and landed there, what India has to install for us. But even before that, I conclude an answer. I gave this for you to answer. We thought that we should build a space station for ourselves. And of course, this is much more justified because we know that a space station will help you to have a continuous presence of human beings in space. We can do a lot of research in microgravity. We can do research in radiation-dependent issues in many, many areas. We also decided we will have continued missions to moon. And for doing all of this, we will build new rockets like NGLV. The programs like Gaganyaan will continue, where human beings are transported. So we have our autonomy mission Nair, who is the director of AeSI, also the first human space flights, and director is here. So he has been a pioneer in ISRO for working on human space flight. I am hoping that in a few years from now, we will have somebody going up in our rockets. But then this roadmap is important for us. I think this is a roadmap for next 25 years. It talks about what India aspires at this moment. But doesn't talk about all those points which I mentioned here. They are all submerged and buried inside. The point here is that if you are to really achieve something like going to land on the moon, we should be technologically that advanced and capable. Unless you develop that capability, that's not going to happen. It's not one of a goal that we need to achieve. It's a trajectory of travel to reach there. It involves technical upgradation, new capabilities, investment. Money also is needed. And the money part is also very clearly there now in the government. They are ready to invest. And I must tell you, this whole of this effort will take you something like 1.5 lakh crores of worth of investment. So it's a good thing that we are now hearing that government is willing to invest that much of money for helping us to grow the space sector. And only if we grow this space sector, everything else is going to grow. It's a very clear understanding. It's a very organic system. National investment and private investment will go together. If national investment is not there, private scaling also is not going to happen. It's a very interesting understanding at this moment. Now let me also tell you that the exploration side is also strengthened. You would have heard that recently there has been an announcement that we are going to Moon again, we are going to Mars again, and we are going to have a Venus mission. You'll understand that when you want to take up such projects, what really happens in space is that the current way of doing things won't work. You need to look at how you can do it more compact way, new electronics, new algorithms, new autonomy, new sensors, everything is developed in the organization. And this actually helps you to work on complex cutting-edge technology. So all of these projects don't really bring in economic benefits, but it actually scale up the skill of the people. So many new technologies were developed during our Mars orbiter as well as Chandrayaan 3 missions, which is actually feeding into building better satellites and better technologies. Now, exploration, I think it's globally an impressive thing still happening. We thought that exploration of Mars, Moon and other planets have stopped world over. No. Every nation is finding a reason for justifying investment in space, especially to understand the universe. And human beings always wanted to understand the universe, and that's only one way, use space technology to put your instruments up into space. The recent launch of the James Webb Telescope from USA, one of the costliest ever satellites built over the last 20 years, is a classic example of finding new science possibilities. So NASA have many programs, but of course, occasionally due to President's whims and fancies, budget get cut, but it will get restored by their parliament or whatever they have. So it goes on. Political and other influences happen. Now you see Russia is not investing much in space, but China is investing more in space. And globally this politics will go around. But still nations find it interesting to invest in space. Europe has a huge science-oriented projects and programs, continue to do that. Robotic missions. Similarly, Japan is also investing very well in. Many of these are available to you from online where you can find out. China has a lot of programs to go to Moon, study gravitational waves and things like that. And everyone is trying to create a capability for human spaceflight at this moment. When everyone is equally talking about robotics and capabilities and move human out of the danger zone and work with the robots, but human being is still not taken fully out. I think you also may ask me a question, why human? Why can't I make a robot that will go there and do the exploration? I will also support it, provided the robot become as good as a human. I think at that moment, there is no longer human being need to travel. And possibly at some point in time, when you have a sensors infused in you that you can actually replicate a human to a robot, and you can actually control the robot through your thought process or sensory perceptions. At that moment, I think we will send anyone to, no longer will send human to space. The key is the reusability, but reusability is still eluding everyone. Elon Musk is successful, Jeff Bezos is also successful. Maybe you need to be an IT giant to really become a reusable rocket expert, possibly. So in India, an IT giant possibly can become a reusable rocket builder, because you need investment and money and risk-taking capability and ability to fail multiple times. This is a big issue in rocket development. I see a lot of startup companies trying to develop rockets, but if they fail, they are doomed. Unless they have a backup of money. I think rocket business is such that early failure handling is a big issue. And this was the strength of people like Elon Musk and Jeff Bezos. They had enough money to back up in case you fail and then work again and solve the problem with expertise being found in. I think this is a core issue. Even for India, we talk about a new Elon Musk will emerge tomorrow. The emergency is all function of this part, money. I think the big companies in India need to invest in this to create this capability. Even ISRO is still not able to work on this possibility because the investment required and other things are still lacking. But then there are work happening across on domains like green propulsion, electric propulsion, and nuclear propulsion. Nuclear propulsion is once again come to the limelight in the recent times because of the specific needs, because you talk about compact reactors. Heard of them? I think everybody talks about compact nuclear reactors. So huge nuclear reactor days are over. Make a reactor that will fit in a room or even a small place, sometimes in your rooftop, generating few megawatt of power. And if you can do that, a village can be powered, a city can be powered, an industry can be powered, and they can be charged and forgotten for next 20 years. You don't even have to touch it. Such nuclear reactors are currently under development, and there is a technology transfer work is going on. India is also working on such areas. So nuclear energy-based propulsion is once again coming to the limelight, including other hybrid and electrical propulsion. Additive manufacturing is a great area. I think for people who are mechanical engineers, manufacturing engineers, should look at very, very seriously. Everyone is talking about additive manufacturing, but the crux of the problem is additive manufacturing cannot be adopted without understanding it. I think this has its own potential risk, especially in the domain of metallurgy. Those who know how metal additive manufacturing is used, possibly you would have seen plastic being printed, but then when you get into metal, it is not easy like this. They look very good, but then they may fail at any moment without warning if you do not handle it very carefully. Issues like high stresses, thermal contractions, design features, metallurgical aspects if not studied. So one of the important roles that we need to work in this country is on the metallurgy of additive manufacturing and building machines ourselves. And today even this technology is being imported from everywhere, and India is not building its own, except where we started somewhere on building powders of our own, building technology of our own. It's very important for research to happen in this area. I'm very happy that little bit is happening here and there, but this has to be much more focused and oriented. Another area is called space domain awareness. You know, there are companies in India who is working on space domain awareness. Possibly you don't know, there is one company in India, in Bangalore, who got an order from US for putting a sensor in space for observing other satellites. It's a very great thing to happen. They have demonstrated after so many years of hard work. They launched PSLV, and they have now launched independent satellites to do the services. So observing satellites, monitoring satellites, looking at how they collide each other or interact each other is very crucial, like a traffic management services. If somebody who is interested to develop an algorithm sensors for it is most, ISRO has also developed this one capability, but ISRO doesn't have its own monitoring network. We have only analysis capability. Given the data, you can analyze. But how to monitor them? How to track this 20,000, 30,000 satellites and objects? We do not have radars, we do not have capability at this moment with the scale that is needed. For example, I talked about the telescopes that are put by across the buildings across the world. We could even do that at a low cost. I think something that we need to work on. Possibly CET can also start doing some technology research in this. Another area is called small satellite constellation. I saw somebody building small satellites here. So that's the beauty of this. And we couldn't have ever imagined that somebody can build a small satellite in an institution a few years back. Today it is possible to build a fully functional satellite in small footprint and do a meaningful work out of the technology. This is a great thing to happen. Because sensors have become very, very compact, the propulsion even compact, power, computational capability, and all of this are being put in such a small footprint that you can even imagine to put a functional, not demonstration, a functional, useful satellite in a small footprint. And this can be realized by people at a cost which is affordable for institutions and nations. Because of that, earlier we had only 5 nations, which are 5 or 6 nations working in space. Today, at least 100 and odd nations have their own space programs. I've seen space agencies come up in many nations. And what they have is maybe 5-6 people, but they own satellites, satellites they own. Because you can buy satellites and launch, and then say, I am also a spacefaring nation. So there are many nations like that now. So this is a great thing to happen because it brings in new capability of design, capability, sensors, utilization, etc. But there are a lot of challenges in building these capabilities, includes critical technologies. Where from you are getting these components and ideas and devices? And they are not manufactured in India. And we need to find out people who will be able to handle this in workforce, in testing, and many, many other areas. People who build these satellites don't even find a place to go and test it in India. So this becomes a limitation. How do you really create knowledge centers for helping young people to build satellites in this country? I know at least there are 5-6 companies who are doing extremely well in this country now, building their own satellites as good as that ISRO can do. It's a really great thing to see. fusion of EO and PNC services. I already explained, so I won't mention on this slide. So another area is satellite subsystem supply chain. Here again, I want to tell you people that there is a great opportunity. You know, when Maruti came 1980s, Maruti started building their cars. I think you are not of the generation, I am of that generation. So when Maruti car came, before that there was only one car, you know, Ambassador. And the Maruti created a manufacturing ecosystem in this country. At that time, the kits were coming from Japan and a little bit of assembly was done in India. But slowly the ecosystem was developed in the country to build tires, glasses, sheet metal, chassis, castings, sensors. Slowly, the ecosystem got developed. Now this became the supply chain for many other companies who want to create cars in this country. They can actually source from this. So essentially what I am telling is in satellite building also same thing has to happen in this country. There should be multiple companies who are able to assemble satellites sourcing the same parts and components which are specific or standard made from many sources. So there is a great opportunity for this country to develop such capabilities, controllers, solar panels, composite structures, propulsion, tanks, cameras, sensors. If somebody can specialize in this area, they become the supplier of these devices for companies. And this is happening today. I think some of the companies are focusing on, for example, one company in Hyderabad is focusing on solar panels only. So they will supply solar panels for every company. They told me the other day that I have a RFP sitting which is worth 2,000 crores. I am unable to do. So look at the scenario of that company. So we have a demand profile we are unable to meet because of many other constraints. So there are so many areas possible for us to create companies and businesses who can actually supply this, not for Indian companies, globally. And these suppliers who demand are not from Indian sources. Global supply chain, demand components to manufacture in India and supply. It has been happening in aerostructures and many other areas in aircrafts. Possibly you don't know, Airbus and Boeing aircrafts which you travel, many parts are made in Bangalore, Hyderabad and many other places, including nuts, bolts, etc. Now today, I think this is a great chance for us to work in space in a similar line. It's a great things, but there are a lot of challenges, and it will happen only if you create new companies and businesses. Similarly, AI is also coming into space in a big way. I think all of you know AI, I don't want to explain it, it can help in many areas like autonomous operations, data analytics, Earth observation analysis, mission planning, many other things. But its challenges are, of course, you know that explainable AI, limited training, data availability, reduction in use, disturbances, certification. I think all of these are part of the AI development journey. Robotics, I think this is slowly catching up. When I mentioned human and robots, this skill is very important. And new companies are coming up in robotics. I don't know whether you know that in Kotaragara there is a robotic company just started by Soho on robotic R&D activity. So Kerala is also a very interesting place for robotic development activities, and this must be used strongly in our favor because you know it's a mix of domains, mechanical, electronics, algorithm, software, material science. All of this come fused together to create robots. We also have plans to dock robots. We did a mission called SpaceX recently. We are also building the Vyomitra who will go and do some sort of activities, language processing, similarly refilling and fuels, things like that. So this and debris removal. And recently one company started for debris removal. One of these fellows is starting a company for going and catching debris and deorbiting it. Maybe I wish him all the best because there are enough debris there to be caught and brought back. So these are things that are happening now in our country. But then another area, technology area is in communication infrastructure. I mentioned already on the software-defined systems. Software-defined systems, everything is now software-defined, cyber-physical system, mechanical, computational, sensors, algorithm fused together, you create a communication infrastructure, joined together to create a cyber-physical system. But this is also happening in communication infrastructure. Software-defined radios are integral part of satellites now. Earlier we used to operate in a fixed band mode, no longer possible because frequencies are very becoming limited, there is a cluster there and signaling. And the demand of the ground is also changing dynamically. Earlier one satellite you launched, next 15 years it will work. Today, after 2 years, they want a change. The user has changed. The evolution, communication technology is changing so fast. You cannot have a latency of 15 years or a survivability of 15 years, not possible. Similarly, a lot of new areas, including quantum and others, are emerging. So, your challenges are, of course, big when you drive towards software system, the cyber security challenges are huge. And even for us in ISRO and others, we've had a huge amount of threat from cyber attacks, both in space and the ground segment that operate space. So it is being surveyed very carefully at this moment. Similarly, electric powered systems. I think satellites are already becoming electric powered. You may be knowing that there is an electric propulsion work which is happening in ISRO. We are already going to launch one of the satellites now using solar power and then generate thrust using plasma generated out of inert gases. Equally important is electric powered aircraft are also coming. I think this is a new change. I just know that aircraft is not part of the space, but still, electric vehicles are already there, happening in the ground. It's so happening in space as well. Only want to tell you that slowly the electric mobility will become a huge area. But then other domains of technologies are emerging. But then adoption of this technology in space has its own challenges, primarily electric propulsion. Currently for India, all of them are purchased from outside. There are enough of companies in the Europe and the West who are developing electric propulsion. In India, there is only one company developing in Bangalore, I know them. Otherwise, it is only ISRO. So even that area, there is not much of research work happening, which is very important and useful work. I think a lot of R&D need to happen in India in material science, plasma dynamics, power electronics to make this happen. So the critical technologies that we need to harness, I think I am summarizing what I mentioned now into a single slide to tell you that we need to look at reusability as the most important topic if this country needs to scale up space. Then only we can have large number of rockets, large number of launch opportunities and provide capability for satellites to be launched in numbers. Very key. And we are already delayed too much, and I think we should be on that job only. Second is radiation hardened, space grade and space upstream microelectronics detectors. This is a huge issue for India. So if any company want to build satellites today, you start buying electronics, it's simply not available. If you have to build a camera, the detector, the company won't let you. You place an order, it will take you 1 year, 2 years to get that device. So unless you put an effort to do fabs, which will be able to manufacture detectors, it's called microfabs. Today there are fabs across the world called microfabs. You can actually create them with low investment. And this can actually build detectors and other key components of space at a low, maybe per piece cost will be higher, but you will get it in few months of time if you can actually do the design. And we are not very good in design of it, but in manufacturing we do not have capability in India. This is a key. Of course, that electronics chip manufacturing revolution is happening in India, and all that investment is happening in the commercial chip sector, not into the high technology space sector. This investment has still not happened. And this is one area which I am also trying my best to bring into many of the institutions which I am connected. Similarly, software. Today you see there are many companies developing software for space. Exactly like car manufacturing, you see the car software is not done by the car companies. You know that? And most of the cars are now software driven and computer driven. Typically in a modern car you have 30-40 microcontrollers. And the software for the cars are not written by Maruti, software is not written by Maruti. Hyundai's car is not written by Hyundai. There are companies who are actually building the software, they subcontract and they develop the software and supply to this company, including the front end and many other experience systems. We actually need software companies to handle space sector. Every company start developing software, this is not going to work. I think everybody is reinventing the wheel, putting people into it, and too much of cost. So why don't you start a company for developing space software for space? They will sell software for anyone who wants anything. I think that is another company that you have a great opportunity to happen. Similarly, there are areas like optical systems and cameras. Today, the cameras for all the satellites are purchased from, places like South Africa. You will imagine South Africa is a very good country, but because of one few individuals, they created a company in South Africa. They are building rest of the cameras, and that is being used in Indian satellites. It's a shame for us. I think with that type of skill that we have, we should be building a camera-making company here. Similarly, radars. There are only 1 or 2 companies in India who are actually working on radars, which can go to space. Propulsion system. There are no companies in India who are building space propulsion system to a level of maturity. There are companies, 2, 3, small propulsion for satellites. Other than this, there is no one capable. It's a huge market today. Electric propulsion and chemical propulsion, who can actually build. And many other areas, materials, special materials, etc. So I only want to conclude saying that the opportunity that is there in front of us in space due to the global expansion of space is huge for us in India. Every layer, building rockets, reusable rockets, building microsatellites, supply chain, component, software, integration, testing, the possibility for you to create entrepreneurs, possibility to create ideas, possibly it could be, you can actually bring in technology from somewhere and start the work. For over a period of time, you can actually grow. Any startup company who has started with a great vision in India is actually faring exceedingly well. Some of them are valued even before they actually go to market at a high level. I think this is something that you people should explore and find out what is happening. When I travel across and interact with these people, I'm really astonished to see the possibility and growth, but huge challenges ahead of them, some of them which I already mentioned. So I want to conclude because it is for young people who want to jump into domains and looking for their opportunities and career goals. Possibly this would help. Thank you so much and all the very best.
Thank you very much, sir, for your most valuable insights. Now we have an interactive session with our chief guest. Audience may now ask questions.
It's an interactive session now. So anyone who wishes to ask questions or clarifications or anything you have wish to ask us, this is the best time for it. Just raise your hand and we'll give you the mic.
Gopalji asking, he is a veteran.
So while in your presentation, I had one point that some of our satellites also, some friends have come and then they have discovered, if I understood correctly, was something like that.
What I spoken is good enough.
So like those kind of possibilities are already there. It is explored.
Yeah. What's there? It's not a possibility. Again, I want to tell you it as factual. Yes. And many more, which I did not talk.
So before the students picks up, I thought from the part of academics, just thought I'd share something with you. So normally from our days of learning, when we were trained more on the solutions, technology, now it depends on the huge responsibility lies on all the students to identify the value for which the technology is being learned. So there is a roadmap which they have to stitch around to reach the solution. So can you just comment upon something?
No, this is interesting. I think what he said is, now I will explain what this question is. From the days when we were students to the students what you are today, you look at every subject whether it is work for me to study or useless for me to study. This is a very interesting aspect of the current generation. Current generation looks at it utility. They are not interested in studying for the fun of study. I think that days somehow vanished. We were forced to study or studied because of the fun of studying, whether not thinking whether it will be useful to us or not. This is a change which is happening, and many. I have been. I was there in IIT Chennai as an evaluator for one of the department. I found that even IIT students don't even come to the class to study topics which are of their own interest. They spend their time something else which they will bring them their career goals or get their jobs. It's a change that is happening. We have to accept it. The point today is that if you can learn anything new if you want, you don't have to come to a class. You don't need even a professor today to learn anything. And it's a good thing to happen. So the college need to understand that the relevance of colleges like this is changing significantly. And the way in which you students learn skill is also not teacher oriented any longer. And this is a reality. And this reality requires a different way of teaching. No, the teaching requires a set of fundamentals which are essential to enable you to learn becomes an important part of it. The second layer of learning is voluntary. It is their job to study. If they want, they will study. If they don't study, they perish. It's their fate. And it is not becoming teachers or universities or colleges' responsibility to train them to do that. If they don't want, that's it, over. So you don't have to teach everything. That's also there. So especially they should identify their passion and goal at some point in time during the course and take courses with lot of freedom. Not the one which will give them great grades. No, that's not the way. The one which will help them to achieve their goals. And if you can do a little bit of mentoring to identify during maybe second year, third year, what exactly they need to do through a counseling, etc., and identify courses, allow them to take that across disciplines. For example, when you become a mechanical engineer, you think that you don't have to have a skill in software. No. Today we need deep knowledge in writing codes and AI or anything like that. They should be allowed to take courses. I believe it is already happening. But that will allow them to take their path. And if they want to learn deeper on metallurgy, material science, thermal and all that is needed, they will study if needed. But they are not to be taught everything. That is not necessary. The basic physics is same for across all of this. So very rigorous mathematics. I think there shall be no compromise on mathematics. I think this is a weak thing here. There shall be no compromise on mathematics, there shall be no compromise on basic physics. Okay, once you teach this, rest is now anybody can learn. I think that's how courses are to be engineered, and that's how the modern way of teaching also has to change. You know, a lot of debate can be there, I leave it to you. Okay, now we'll go to the other questions.
Good morning, sir. I am Suraj from S6 Applied Electronics. So my question is regarding microelectronics and nanoelectronics. As you said, we are sourcing the components from outside. For example, in our science lab itself, we source many components from outside India. So what can be the practical solution? For example, ICs and chips, etc., are sourced from outside. So what is the practical solution for that thing? So that's my question.
See, the solution is to create an ecosystem in the country. So that, for example, what are the real problems? For example, you know, the fabless work is very greatly happening in India. So converting that design to prototyping or product, that process is weak in India. So one method is to create a large pool of skilled people through creating some fab-based training centers across the country. So if you really look at the fab-based training centers are very small in this country. See, one is there in the Institute of Science and some other few locations. So how many people are coming out who are knowledge in setting up foundries? Not there at all in this country. There are only a few people. So that's why there is a hesitation to build the foundries here. There is a hesitation to even think about building equipments here. So there is no training facility. So I met one fellow who was in SCL, you know, Chandigarh SCL. He resigned and went to Singapore and established one of the best of foundry, an Indian. He established one of the best of foundry which is actually making most of the processors that are being used in all your mobile phones and devices today. He came back to India, he says, I want to set up something for this country. So there are a lot of people. I think we need to bring them to do this slowly. It takes time. We missed some time back, but we not any longer miss. Because that step is being taken. Of course, it has an investment issue, which is huge, because if you really look at a commercial, chip manufacturing, only Tata fellow, whatever they are doing in Gujarat and Assam only can work, but that is not going to solve the problem because they are working on some commercial large-scale products like memory, small-scale adapters. But really, you need people who will actually work on designs, who somebody can take over and then produce in large numbers.
For example, specific kind of ICs and ASICs are not available in India.
Yeah, all of these are part of that whole system because chip manufacturing is a monopoly. I think all of you know that. You want to create a fab, you cannot do that because the machines are only one fellow is only making. So ultimately, the whole thing comes down to the issue of IP. Okay, so that IP is not available. So, but what do? You need to create from the basic start from the from the lower level. When we started rocket building, we also had no IP. We built over a period of time. It takes sometimes 20 years, 30 years to develop it. So somebody has to start now. So start small fabs. From whatever you can kill, beg, borrow, bring it here and start. That's the only thing I think that's happening. And we should compel business houses to invest in this. Because normal people cannot invest. We need 2,000 crores to invest. So such things are happening. But then it's only government can do. None of us can do anything. I think the policy from there only will drive it.
Thank you, sir. Sir, you mentioned that there are currently a limited number of launches in India. So, say if a private company requires a deep amount of investment to produce a launch vehicle, so ultimately how does it become economically feasible, providing that there are only limited launches?
It becomes economically feasible because there are only limited launches.
Sir,
The limited launches in India is for ISRO if you want to launch. The satellite has to come now from somewhere.
yeah.
Satellites are plenty in India. Today, I have seen companies who are building tens of satellites today and there are no launch ready for them to launch. They went to ISRO and said that there is no slot available for ISRO to launch. I know at least 4 companies, they said that I don't have a slot in ISRO, not in PSLV, not in SSLV, and they are getting launched in SpaceX and the other one, Electron, and many other launches are also scheduled. They don't give a slot.
So, sir, so the growth is so exponential that the feasibility automatically becomes after 3 to 4 years.
If you are ready with a rocket today, you get an order. I can tell you. Do you have a rocket? I'll give you an order. Because there are people are behind me. They don't have a launch opportunity. That's the situation today.
Hi sir, my name is Anurag. I'm currently a EC student. So as we told about the space debris, I read about it that at the current rate of space debris, we could move into a age where we are not able to send more satellites because of the difficulty in tracking all the space debris and calculating the trajectory for our satellite. So do you think that such a time is very close that we should do something very fast?
Yeah, we should do something, definitely. But this is something is never happening. We know that our traffic jam is very high. So anybody putting a restriction, the number of cars that can be sold in Trivandrum will be upper bound will be only this many numbers per month. Will you be able to do such an order? See, you know that number of road available and everything is fixed. So, you know, the demand of the society is different and constraints are different. Sometimes the constraint doesn't become part of the decision making of the demand of the society. You don't decide on buying the car based on the number of cars on the road or the capability of the city to handle that traffic. You are adding more roads to the city. It is same for every company. They are not worried about it. Now who will worry about it? Global community should worry about it. And they should find out ways by which this large number of satellites can be handled. How will you handle? You bring discipline. Say, the discipline in space was not enforceable some time back. No, you need to enforce. What exactly are the discipline? Discipline is that the space is very, very vast. The distance between satellites are in kilometers, sometimes hundreds of kilometers. That means you can accommodate more satellites there. There is no issue. Only thing is you need to regulate and control that movement. And then you must have a method to know this, and in case that you have a problem, you need to move it out. Exactly like a traffic. So, more physics need to be there, more observation need to be, more regulation need to come. And this will come in orbital knowledge, propulsion system, like passivation, aerobatic principles, sending the signal of that position to a common infrastructure on a continuous basis that should be mandated so that they voluntarily inform I am here instead of tracking it. I mean, there is a method, you send a signal and my trajectory data is continuously sent. So there are methods that are to come. So there are bodies, global bodies like UN bodies discussing. But what happened is these global bodies are also weak. They are not enforceable. You see now the scenarios across the world. People like UN Corpus where this has to happen has become very ineffective. Even United Nations has become ineffective in even the conditions of war. So global desire to do this exists, but the power of the global community to enforce it is still not existing. So until it becomes a threat, all of us will be sleeping. So threat is almost near. So let us see.
Sir, is that time do we have that time before we find a solution, or is it very close that
I don't know that. See, recently Elon Musk filed a application for 1 million satellites to be launched in the next 5 years. 1 million satellites to be launched in the next 5 years. So there are a lot of lobby happening against it. Some people are going to UN and others as representation. They are also telling me you also put some tweet against it. I don't want to put. Tweet will not help. Say, he has a business plan for 1 million satellites. And he will do it also. Because there is nobody telling him, don't do it. If you say don't do it, who is not going to listen? And he knows how to handle 1 million satellites. So this is a problem today. So maybe more voices have to come. Opposing the technology is not the solution. Finding solution through another set of technology is the only solution. No, there is a regulatory body for space for certain things. Current regulations are only for geospatial orbit, and it is called ITU and orbital slot allocation. Both happens, but not for any other orbit. So frequencies are of course is regulated through ITU for all orbits, whereas position physical orbit is not allocated by anyone.
So I'm Abhinav Rajesh from Guidance and Navigation Control, first year. So the question is, given your leadership in both launch vehicles and human space flight, how do you see the AI capabilities of Yomitra evolving beyond just monitoring? Could it handle complex autonomous maintenance tasks in future space stations?
Yes, of course, it should. Currently, Yomitra is not designed for that. One other thing that we are thinking is when you build the Bharati Antariksa Station bus, is that it should be autonomous. It should work without human being present inside.
So it's just a half humanoid. Can it walk?
It cannot walk at this moment. It is half humanoid. It will only sit. It will not walk.
Have you thought of any developments where it can walk?
See, I am not the one in ISRO who will answer any of their thought process of ISRO. There are many things. Actually, I will tell you what my dreams are. Please down. Is that robot should become autonomous to handle functions on its own. So when we are reviewing the Bharati Antariksa Station, we discussed how to operate a space station without human beings. Like a space capsule goes there and docks, cargo inside should be moved inside and put in racks. We should conduct experiments and send data. Robot need not look like human beings, no? There is no need that they should look like human beings, the head and hand and eyes and all that face. These are all unnecessary things. Okay. What we need is functionality, and functionality comes out of the only important thing is dexterity of the hand. I think this is the crucial part of the human capability. And the second aspect is your analytical capability, that you don't need a head like this body to show that. You can put a computer anywhere to do the same function. So essentially you need two hands and mobility. So a functional robot with the mobility and dexterity is good enough. That can pack any shape. It can be a dog with the two hands, no head. So the shape of the robot is immaterial. It is not Yomitra or something else. But Yomitra gives you a good feeling. It looks quite human to you. So we are looking at why don't we build a robotic arm in the space station to do all these functionalities of unloading cargo, placing there, starting experiments, removing cargo and putting it back. That conceptual discussion now happened, and ISRO centers are designing this robot currently, and it will take its due course and course of time. It may not be looking like Yomitra, walking robot, human robot, because that is another domain. For example, I will strongly recommend they are required on Earth first, because we need soldiers who will do wars and fighting. Why to send our human beings to the war zones? Let a robot go with the gun and fight wars. Is it not? No, we should be able to design a very agile and capable soldiers which will go there and deliver a bomb or do operate experiments and things like that. That should be the first thing to do before you go to space station. One of you designed it, good robot which will walk on the earth and do all these functions.
Hello sir, my name is Aspirations from Industrial Engineering first year. So my question is, what do you believe will define India's space leadership in the next 20 years, like cost efficiency, deep space missions, or technological independence?
I didn't get the question yet. So once again you said, tell me, once again.
What do you believe will define India's space leadership in the next 20 years, like more concentration on cost efficiency or deep space missions or like technological independence?
None of this. See, what we lack, I was very clearly describing. We have done fantastically well in terms of demonstrating that space can function and do certain things. But if you want to go next step, is scale and economic outcome. If these two are not there, it will go like this only. Now you will see, you will be behind somebody in 10 years, and you will only be showcasing what others did few years back. This will continue, and we will always trail behind and do this on a continuous basis. And if you want to change it and do something very dramatically different, then what matters is nothing but money. When you say money, it's not the investment. Money means something that actually can change people's life. For example, how we are a great IT software developing nation because it has created value. Today, thousands of young people are getting jobs because there are IT companies. Those salaries may not be high, but you get a lot of people get jobs. Otherwise, what would have done India with this much population? Just imagine. If this technology has not come to India and we have not mastered it because of some of these companies who invested in it, you have lakhs and lakhs of people working in that sector, which gives a certain economic prosperity to this country. Now, today you look at if space is not providing that type of prosperity at some point in time in terms of economic activity, it will not grow. It will stay there. And this is a huge issue. That's why we said that we should have large-scale private space companies who will be serving global space market. And India has an advantage in doing it. Exactly like IT revolution. Exactly like IT revolution, we should create a capability in Indian space sector to serve the global sector. And if that skill comes, the next phase of evolution, what you mentioned, technology superiority, better products, all will happen. So first and foremost is a business sense about the whole thing. Technology has reached a level now we are talking one par with others. That is not enough. Now I need to conclude, I need to go somewhere.
Once again, thank you, sir. Firstly, we would like to express our gratitude to a small gesture.
So now I would like to humbly request our chief guest to present the certificates of recognition to the office bearers and the executive committee members of the student chapter of AeSI CET. The list of the members will be said shortly and they will be presented their certificates right now on stage.
Abhimanyu A, President.
Next, Srivardhani, the Vice President of AeSI CET.
Abhirami P.S., General Secretary.
Next we have Hari Krishnan, the Treasurer of the Society.
Sunil Kumar, the program team head of AeSI student chapter.
Next, Murli Krishnan VP, the publicity team head.
Next, Shriya Rajesh, content team head. Next, Shivahari Pradeep Kumar, content team head. Jishnu Rajan, media team head.
J. Karthik, the media team head.
Dheeraj MS, executive member.
Kailashnath A, executive member. Sevilakshmi VP, executive member. Clint Samod George, executive member.
Lakshmi Anup, executive member. As our session comes to close, we welcome the Secretary of the AeSI CET Student Chapter, Ms. Abhrami Pierce, to deliver the vote of thanks.
On behalf of the Aeronautical Society of India Student Chapter CET, I extend my heartfelt gratitude to everyone who made today's event truly remarkable. First and foremost, our deepest thanks to our Chief Guest Dr. S. Somanath sir for delivering such an amazing and interactive session. Your insights into India's growing role in the global space ecosystem, the future of innovation, and the inspiring vision you shared is leaving an everlasting impact on all of us. It's an honor that today also marks the inaugural talk of Dr. G. Madhavan Nair lecture series, and we are privileged to have had you as the lead, sir. A profound note of gratitude to Dr. G. Madhavan sir for the legacy, guidance, and blessings that continue to inspire generations. Thank you for your unwavering support and encouragement for this initiative, sir. We express our sincere thanks to our principal, Dr. Suresh sir, for gracing the occasion with your presence and for always supporting student-driven activities. My heartfelt appreciation to Dr. Abhilash Suren sir for your continuous support, for coordinating seamlessly and for guiding us throughout the organization of this event. We wholeheartedly thank the AeSI Trivandrum chapter for giving us this opportunity and the entire student chapter team for their dedication, teamwork and the efforts behind the scenes. A special thanks to all the participants who joined us, especially those who made the effort despite the college union election day. Your questions and active involvement added immense value to the session. We are so happy to see a fully packed CETA hall today. A warm mention to Deepak from Shutterbugs team for handling the YouTube live stream and ensuring the session reached a wider audience smoothly. We also extended appreciation to all the deans, faculty members, technical coordinators and everyone who contributed directly or indirectly to making this inaugural lecture a success. Thank you all once again for your presence and cooperation. Wishing you a wonderful day ahead. Thank you.
To our entire audience, thank you very much for joining us today. And of course, this is not the end. On the 26th, which is day after tomorrow, as part of the IGX TERAX event, we are hosting an expert talk session, an online talk session, happening, which is delivered by Sri Balanamurthy AeSI, the Group Director of the Structural Dynamic Division of the ASSC. We hope to see you all there, and please feel free to join us on that day. Refreshments are currently provided outside the hall, and once again, thank you very much for joining us. Until then, next time.